Good evening, guys. Tonight we're going to talk about solving systems of quadratic equations. That means that we're going to look at it on that coordinate plane when we have a line passing through a quadratic, how to determine where the points are, the ordered pairs are, for that solution. Let's review some things from our past. Make sure you title this and write down your essential question. The three ways we've already learned how to solve systems are by graphing, substitution, and elimination. In class, we've talked about graphing. Tonight, I'm just going to talk about substitution and elimination. My favorite one personally is the substitution, though. All right, so let's jump right into some examples. Solving the system by substitution. Remember, you have to have variable equals for one of these, and luckily we both have them set with y equals. So we're going to set them equal to each other because we're looking for the point in which the two y's are the same. So I'm going to set 9 equal to x squared plus 9. What am I going to do to solve? I'm going to take away 9, take away 9. 0 equals x squared. Take the square root, take the square root. X equals 0. All right. So this means that this line, this graph right here we're looking at is this, they only cross once at that, probably the vertex more than likely. So we're looking for an order pair. We have x, we know x is 0, now we need to find what y is. We're missing what y is. So we're going to plug it back into our equation. So y equals 0 squared, I plugged it back into this one up here, plus 9. 0 times 0 is 0. 0 plus 9 is 9. And we figured it out. Done. All right, let's go to number 2. So we both have them, they're both set to y equals. So what we're going to do is we're going to set them equal to each other. Negative 5x equals x squared minus 3x minus 3. Now we're going to look at solving for x. I'm going to combine both of my x's. I'm going to add 5x. I'm going to add 5x. 0 equals x squared minus 3x. Oh wait, 3x plus 5 becomes plus 2x minus 3. Sorry. All right. Now I'm thinking of my zero product property if I can, because factoring's easier. Let's see. What would add to 2 but multiply to negative 3? Add to 2, multiply to negative 3. Negative 3, no, positive 3 and negative 1. There we go. So our box will have x squared, 3x, negative 1x, and negative 3, greatest common factor, x, 3, negative 1. All right, so we have 0 equals x minus 1 and x plus 3. So using the zero product property, we have that x is equal to positive 1 and x is equal to negative 3. Not done yet. Adding one more thing to it, we have to find out what the y values are for this. Here's what we have going on so far. We know that this is going to cross at 2 different points. We've only found those x values of those 2 points. So we're going to plug x back in. And I'm going to look at plugging it into the line up here. So x, negative 5 times 1 is negative 5. So one ordered pair is 1 comma negative 5. All right, now I'm going to plug this x in too. And then negative 5 times negative 3 is 15. And our second ordered pair is negative 3 comma 15. And we did it. This crosses twice, found 2 points. All right, let's go to our last problem that we're going to use substitution with. All right, they both have to say variable equals. All right, so we'll have 3x squared plus 2x plus 1 equals 5 minus 3x. I'm going to combine my like terms. Take away 5, take away 5. 3x squared plus 2x minus 4 equals negative 3x, add 3x, add 3x. All right, 3x squared plus 5x minus 4 equals 0. You do not have to factor. You can actually use the quadratic formula now to solve for where the x's are when they're set equal to 0. So let's see what it looks like with the quadratic formula. Negative b plus minus the square root of b squared minus 4ac divided by 2a. Let's see what that looks like. Negative 5 plus minus the square root 5 squared minus 4 times a3 times negative 4 divided by 2 times 3. Okay, let's see what happens. Negative 5 plus minus square root of 25 minus 4 times 3 is 12, and 12 times 4 is 48, divided by 2 times 3 is 6. Our discriminant is going to be negative. 25 minus 48 is going to be a negative, and it's negative 23, so this tells you, all right, this has no real solutions. Sorry. Yeah, they're not going to cross in this plane that we're talking about. What happened was this. You have this parabola, and this line is underneath. Sorry about that, guys. All right, let's go ahead and look at elimination. Remember, elimination is where you cancel out a variable. So number 4, do we have a variable that we can cancel out? Yes. We have 2 x's with the same, and we actually have 2 y's with the same. So if we subtract, let's see what happens. We're going to subtract. Let me set it up nicely. X squared plus x plus 0, y equals 0x squared plus x plus 5, and I'm going to take away. All right, y minus y is 0. X squared minus 0x squared is x squared. X minus x is 0, and 0 minus 5 is negative 5. All right, we're going to add 5. We're going to add 5. X squared is equal to 5. So now we're going to take the square root, and x is equal to plus minus the square root of 5. I want to keep this as the square root of 5 because it's a pretty ugly number, as in it's an irrational, it doesn't have a pattern repeating decimal. Okay, so now we found out what x is, and x is plus the square root of 5, comma, we don't know what y is, and the other one is a negative square root of 5, and we don't know what y is. So what we're going to do is plug that back in, and I'm going to choose this easy one right here. This is the easy one. So the y value is square root of 5 plus 5, because remember, I don't want to make it hard or ugly, and then the negative square root of 5, square root of 5 plus 5. There we go, and we did it. All right, let's go to problem number 5, elimination. Do we have anything we can eliminate here? We kind of want to eliminate as much as possible. We can at least eliminate with subtraction our y's, so let's see what happens. Y minus y is 0. 9x squared minus no x squared down here is still 9x squared. 8x minus 5x leaves us 3 x's, and negative 6 minus a negative 4 turns into negative 6 plus 4, which is minus 2. All right, we can use the quadratic formula to solve from here now, and we will get negative 3 plus minus the square root 3 squared minus 4 times 9 times negative 2 divided by 2 times 9. Okay. Negative 3 plus minus the square root of 3 squared is 9. 4 times 9, 4 times 9 times 2 is 72, and then this will become plus 72 divided by 18 equals negative 3 plus minus the square root of 9 plus 72 is 81. Ooh, that turned out to be something nice. Divided by 18. Negative 3 plus minus 9 divided by 18. Negative 3 plus 9 is 6 over 18. And negative 3 minus 9 is 12 over 18. Okay, 6 over 18 reduces down to 1/3. And 12 over 18 reduces down to 6 goes into 12. Oh, sorry, this is negative. 2/3, negative 2/3. All right, we found our two x's. Now we have to plug them back in to find our two y's. And I'm going to plug them into the easy equation. And when I plug them in, I'm going to do 5 times 1/3 and then minus 4. And I will find that to be negative 2 and 1/3. So our first one is 1/3, comma, 2, negative 2 and 1/3. And our second one is going to be negative 2/3, comma, negative 7 and 1/3. All right, for time's sake, I'm going to go ahead and move on. All right, go ahead and try solving these three on your own, okay? And then answer your essential question. When you're ready for me to review the answers to problems 1 and 3, play your video again. All right, you should have gotten negative 2 comma 6 and 2 comma 6. All right, two solutions. Number 2, you should have got 4 comma 0, one solution. And number 3, you should have got no real solutions. All right, go take that checkpoint, and good luck, guys. Have a good night.